Either long and involved or test your luck. Here's where you have to guess. You pick one to start with, and you guess. And what you do, well, there's actually 8 numbers represented here. These 4 numbers, positive or negative. Somebody pick one of the 8 numbers.
3. Actually, 2.
2. What's your favorite color? Blue. No red.
Orange.
Okay, so.
Yay, your humor's gonna go on YouTube too.
Fantastic. Good wait. So 2 is the number Dean chose. So I'm gonna do. Hope this goes quickly, or I'll use a lot of board space. Hopefully he's lucky.
My name is on YouTube.
Yes. It's this polynomial. The coefficients are 1, 5, 5, -5, and -6, correct? Did I do that correctly for 1x to the 4th plus 5x cubed plus 5x squared
I don't see why.
minus 5x minus 6? Okay. If I get a 0 at the end, this is one of my solutions. It's one of my zeros. It's one of the places where this polynomial hits the x-axis. If I get anything else, Dean is not lucky, do not have him pick your lottery numbers, and we have to try something else. Pardon? Well, let's find out real quick. So 1 times 2 is 7. 2 times 7 is 14. I'm up to 19. This is 38. This is not going to work, is it? Because this will be 33 when I add them. 66. Good call, James. 60. 2 does not work. So who's got the next guess? Cody, what do you want to try? So we'll do 6, and then we'll try negative. We'll see if we need to try -2 after that. See, but you guys get the idea that we just guessed 2, and it did not work because this is not equal to 0.
Watch 3 be the right answer.
The one you started to guess first. Yeah. Should go with your first instincts.
Shut up.
-5, -6. Okay. 1. 6 times 1 is 6. Now we have 11. Now we have 66. This is not looking good for the home team.
Just try 3.
Yeah, because now we're going to get 71. Do I keep going? No. All right. You see, but you guys see how there's a rhythm to this, and you get to a point where you don't have to, you can just forget it. It doesn't work. Okay, so we've done 2 doesn't work, 6 doesn't work. I think a negative number is a good idea because there's 2 positive 5s in a row. Make things bigger.
-1.
Who said -1? Let's try -1. The advantage of trying 1 and -1, Kara's got a good point, is that they go pretty quickly. All right, so my coefficients, which I should not have erased, were 1, 5, 5, -5, -6. Bring down a 1. -1 times 1, -1. Add them together, I get 4. 4 times -1, -4. Add them together, I get +1. These numbers are staying low. It's a good sign. -1 times this is -1. Add them together, I get -6.
Yep, it works. It works.
6. We got a 0. Okay. Now, 2 advantages. 1, we know that x equals -1 is a solution. We also know that x plus 1 is therefore a factor. So that's one advantage. We've got it partway factored. We've got a solution. Because you can be asked to do either thing. Factor this or find all the solutions. Here's the next piece. We don't have to go back to this. Now we can start looking for solutions of this smaller polynomial. All right, because now we know that the next one is x cubed plus 4x squared plus x minus 6. We can go ahead and just use these 4 for our next guess. What should the next guess be? We still have -6 at the end. So now it's still all these same numbers.
-6.
-6. Kara was lucky here, so I'm going to listen to her again. But now I'm going to do -6 and see if that goes into 1, 4, 1, -6. Bring down the 1. I get a -6. Add them together. I get a -2. Is that correct?
Mm-hmm.
It's too big. So I'm going to get 12, then I'm going to get 13, and I'm not even going to work out -6 times 13. So no, it won't work.
There's no other way around there.
At this point, sometimes you can see patterns. Like, the 2 positive 5s means you want to try negatives. Because if you multiply a positive number times 5 and then again, it's going to wind up getting big quickly. But there's no real set thing you can do to predict it other than, yeah, it's trial and error at this point. Let's try -2 since -1 works so well.
Try 1.
Small negative numbers.
Mr. Belva, try 1, it works.
Try 1, it works, you sure?
Yeah, I just did it. I think it works.
All right, let's try it. So it's 1, and now remember, we're trying it into the shorter set of coefficients. 1, 4, 1, -6. Bring down the 1. 1 times 1 is 1.
5.
5. 1 times 5 is 5.
6.
6. 0.
Yep.
Excellent. So now we know x equals 1 is a solution, and x minus 1 is a factor. Here's another thing we know now. These last there's a difference of squares situation, right? We've got an x plus 1 and an x minus 1. Also, these last 3 coefficients means that our last remaining factor is x squared plus 5x plus 6. If I want to know the solutions to this, I don't have to keep guessing. I can keep guessing with the 6 and keep doing this.
1 and 5.
Or I can see if I can factor it the first way we learned. 1 and 5, that's right. Or you can use the quadratic formula if you get stuck here. Amy thinks this is x plus 1. Oh, not 1 and 5. It's not going to be 1 and 5. That's close.
Oh, -1 and 6.
Nope, because they're all positive. They have to multiply to 6 and add to 5.
2 and 3.
2 and 3. No, I do not. Okay, so our final statement on this. This took up a lot of board space.
Wait, do you put the equals 0 after the after the factor?
Good question. Amy just asked a great question, and I haven't been as clear on this as I need to be now. There's 2 things we just found out. Okay? All right. Our original function, f of x, was, what was it? Actually, somebody read it to me.
X to the 4th plus 5x to the 3rd plus 5x squared minus 5x minus 6.
Minus 5x minus 6. We just learned 2 things. One, this factors down to, our first solution was -1, right? Factors
Yeah.
to x plus 1, x minus 1, x plus 2, x plus 3. Okay, so if you're asked to factor this, this is your answer. If you're asked to find the solutions, well, you find the solutions by setting each factor equal to 0. So the 4 solutions are x equals -1, x equals +1, x equals -2, and x equals -3. So there's 2 different questions you can be asked about this. First one is, what is this factor to? The second one is, what are the solutions? Okay? And this is basically how you start guessing. You get your choices from here, and you guess. And synthetic substitution or synthetic division is by far the fastest way to check your guesses. We could have also done polynomial long division on each of those. I don't think that would have gone as quickly. Yes?
You didn't exactly answer my question.
Okay, ask it again.
Over by the x plus 2, x plus 3, do you put a 0?
If the directions are to find solutions, which is what I said we were doing at the beginning, then yes.
Okay.
Yes. And then the solutions to these would be